Hello, this is going to be our introduction to logarithms. And so a logarithm is a way of describing an exponent. So we have what we call exponential form, which is what we're more used to. So say 3 to the second power or 3 to the negative second power equals 1 over 9. In logarithmic form, that would look like log base 3 of 1/9 equals -2. So we see that you still have the same base, is the base of the logarithm, but now the answer, the value you're going to get is connected to that. And then the exponent is what the logarithm is equal to. So logarithms are really exponents, a way of describing exponents. Because of that, there are rules for them overlap with the rules of exponents because that's what they represent. So base exponent equals value in exponential form changes to log based on the base of the value equals the exponent. And just a quick comment about this, you might remember from your elementary school days when you were learning to write, they gave you this paper like this. So when you write this, this should be log, and your base is a subscript. And then the value is the full size. And then what this is equal to is the exponent in full size. Okay, so make sure the reason I'm just mentioning that is because I've seen people where the beginning of their assignments, they look like this. And then by the end, it starts to look more like this, which is not correct. So make sure you keep that base down as a subscript. So the first few problems you're probably going to do is they're going to give you this in one format and you're going to convert it to the other format. So they may give it in the exponential form and you have to go to the log form, or start with the log form, go to the exponential form. So let's say we start with the log form. We have something like log, I don't know, pi of x equals 7. Okay. How would I convert that into its exponential form? Well, this is log base pi. So my base is going to be pi. Logs are equal to exponents. So 7 is the exponent. Equals, and the value I'm going to get is, in this case, x. So that's how you convert it. Now, if I have it in the other format, we did one of those, but I'll just do another one. Let's say we have 16 to the 1/2 equals 4. And so if I convert that, that's going to be log base 16 of 4 equals 1/2. Log basic. Now, there is a little trick to doing this that sometimes helps people. So let's say I want to convert log, let's say 5 of 1 over 25 equals -2. So the trick is you always start with the base, right? Start with the base. And then you swirl away from it. So 5 would be my first number. That's my base. And then I would go away from it. And that next number is going to be my exponent. And then I swirl back. And this 1 over 25, that's going to be what my value is. And just be aware that if your problem is written as -2 equals log 5 of 1 over 25, same thing, right? Begin with your base, swirl to the -2 equals, so you just swirl away from the base and then come back. And that's the order those go in. So it's just a little trick to keep things in the same order. Sometimes, when I'm looking at students' work, I'll just kind of, with my finger, just kind of swirl it and see if it works. Let's say we have 27 to the 1/3 equals 3. And again, I want to swirl that. So I begin with the base. I swirl away. So this is going to be log base 27. I swirl away. My next number is 3 equals, and I swirl back 1/3. So this is a little trick. You don't have to use it, but something you use to figure that out. So when you're looking at these statements, it's a little easier to switch from log to exponential sometimes because you're getting a true statement. You're getting a true statement both ways, obviously, but it's easier to understand that true statement. So, like, for example, 16 to the 1/2 is 4. Well, that's the case because the 1/2 exponent means the square root. So the square root of 16 is 4. Oh yeah, I did translate that correctly. Or the 1/3 exponent, that is the cube root. So cube root of 27, that is 3. Okay, yeah, I did translate that correctly. Negative exponents, they tell you to do reciprocals. So 5 squared is 25. A negative exponent would be the reciprocal of 25, so 1 over 25. So that does, knowing those rules of exponents will help you understand how to convert that. It's a little, switching to log form, it's not as clear because until you're used to logs, you look at 16 to the 4th, it's 1/2. Yeah, I guess, maybe. I mean, unless you have a feel for what logs are. And hopefully after doing this assignment, you will have that feel for that. But it does require you to know those rules of exponents because logs are equal to the exponent. So the next few problems will be to simplify or evaluate logarithms without using a calculator. And this goes back to the rules of exponents. So let's real quick go over the rules of exponents just as a reminder. And hopefully I won't forget any of them, but we'll see. So any base to the first power is that base. Any base to the 0 power is 1, as long as that base isn't 0 itself. If you have a base to a power and you multiply that by the same base to a power, then you add those powers. If you have a base to a power and you divide that base to a power, then you subtract those exponents. If you have a base to a negative power, you do the reciprocal of that base to that power. If you have a base to a power and you raise that to a power, you multiply those exponents. If you have a base to a fractional power, let me change that. The fractional exponent, then the denominator is your root number. So if it's 1/2, it's a square root. We don't usually write the 2, but that's what it is. If it's not 1 on top, then the bottom is your root number, the top is your power. And you could do the power then the root, like I wrote here, or you could do the root and then the power. In reality, you're doing both simultaneously, but by hand, you usually do one and then the other first. So they will ask you, using those rules of exponents, to simplify some logarithms. And so again, we're looking for exponents. So if I have log 2 of 16, what this is asking me is, what power of 2 gives a result of 16? And that answer is the fourth power. That's the power of 2. That gives a result of 16. So what power of 2 gives a result of 16? And so that's how you'd figure out what goes there. Log 49 of 7. Again, what power or exponent of 49 gives a result of 7? And you go, well, I know 7 squared is 49. So the opposite of squaring something is to square root it. And the way you do square roots with exponents is you write fractions. So square root is 1/2 exponent. So that's how you can do that. Let me